In this session, I'm proud to introduce Unmanned Life, who is pioneering ways to make video surveillance and other robotics use cases more efficient and integrated into your operation. Here's Nicholas, the CEO, to tell you about what they're doing.
Well, thank you very much, Roland. And yes, I'll give an introduction now on Unmanned Life, and we are. So our vision is that the future will be autonomous, and this is much more than autonomous vehicles. This is about autonomous drones, autonomous robots, legged robots, and to unleash the full potential of this autonomous future, we need to approach it as a platform. And today, we want to talk about site security and inspection from an autonomous robotics platform approach. And we want to present this as Unmanned Life with the brain for the autonomous future. But Unmanned Life, we are shaping this autonomous future to enable robotics applications for enterprises and industries invested by Telefónica, Spanish multinational, and TELUS, Canadian telecom, featured by the Financial Times as one of the leading autonomous vehicles companies in the world. And we have more than 15 live projects and 12 countries deployed in. Who we work with, we are partnering with top companies in the industry, global tech leaders like Cisco. As I said, we are headquartered in London with a tech office in Barcelona, and we are partnering with different type of companies from the telecoms, manufacturing, and other type of OEMs and utilities. Now let's talk about today and what is the problem that we are solving. What we're trying to address as a company is the fragmentation of robotics. So I presume that everybody in this virtual room, we all read about reports of how robots are going to bring efficiencies to businesses. But the problem is that the millions of robots that are going to be deployed in the years to come, all these drones that are going to be deployed, they are all running on different software, different hardware. They are not speaking the same language. Even they cannot go from one network to another, from 4G to 5G to edge computing to private 5G. And so they cannot bring all these efficiencies. And we have solved this problem by creating the brain, Unmanned Life Brain, our platform that is enhancing all this ecosystem by autonomously deploying, controlling, and orchestrating fleets of drones and robots. This is our solution, our brain that is enhancing the entire ecosystem. How are we solving this fragmentation of robotics? We are doing this in 4 steps. First, we are integrating commercial off-the-shelf robots, and we are doing what we call the command and control. Then we are connecting them to our platform through wireless connectivity. This can be through 4G, 5G, or Wi-Fi, or edge computing. So we are leveraging the network. I will talk a bit later how we are leveraging the network and how we are an edge native and a network company. Then we centralize the data and we leverage the context and orchestration of all different systems to leverage the power of data to, after we are able to scale and deploy multiple autonomous applications through our centralized platform. So these are the 4 steps that we follow to deploy autonomous applications at scale. Now, we are different in the market with this platform approach because we bring 3 main concepts where we have built our architecture. First, interoperability. We know that this is key to scale autonomous robotics. Then flexible, because you need to be able to be flexible as you deploy different type of robots, and then being open to integrate to other systems. And this is how we have built our platform since we started as a company. And our principles and our architecture, and I'm going to show in a second. We have been recognized by different key players in the market, Financial Times, the GSMA, the Telecoms Trade Association, and the STL partner, the Gartner for Edge Computing. So everything you need to deploy autonomous robots at scale. So now, why deploying autonomous robotics from a platform approach is important? First, we all know here that integrating new robotic systems into large corporations, it is disrupting, takes at least 6 to 12 months because you need to onboard into IT and server infrastructures, networks, interfaces, vendors. You need to go through security protocols through existing processes. Think about the different type of robots that I'm showing here. You always need to go through all these vetting processes. So it takes time, it is costly. So if you're introducing new use cases, this is what I'm showing here, the typical and traditional approach. Imagine you are an energy company and you have different robotic use cases that you are currently deploying, security, an inspection use case, and a safety inspection. You have 3 different types of robots. You are using different type of controllers, different type of networks, and different type of softwares and infrastructures. You need to go through all these different interfaces. Every time you integrate, you need to go through all these hurdles. With our approach, you have the platform approach with Unmanned Life, where you are simplifying the integration and you go through a much simpler architecture where you have one platform that is facilitating the integration of multiple type of robots, still having different use cases, but you still have one network, one platform, and different interfaces and integrations. The benefits of a platform approach versus the traditional approach is that you can have scalability. The modular modularity that you can get through these applications is that basically you can use the same system across different use cases. You are reducing what I was referring to before, the integration cycles, and you have the same robotics interface. Very important, we know, is the security layers, and I will be talking about how we are ensuring the best cyber secure mechanisms. But with this type of platform approach, you can ensure that you have the same layer safety mechanisms. And when you have a platform, you can have the platform level best practices. You can have one platform already vetted by the network providers and the critical infrastructure companies that you have done this. And we have been through that already. And then when you have a platform approach like us, where you are hardware agnostic, you are totally independent from hardware and vendors. So hardware becomes a commodity. And this is key when you want to build your own robotics roadmap. And then you can quickly add applications to existing systems and processes. You can think totally strategic. And this is what we are suggesting here. You need to think how you can build your scalable robotics roadmap. So we wanted to build this graphic to show how a platform approach, instead of going in silos of, I'm going to deploy drones for a specific use case, I'm going to deploy drones and ground robots for another use case, or legged robots for another use case, you can have a platform to build your different use cases from a holistic perspective. And a platform that is integrated to your systems is really enabling this scalability and this integrations perspective from day one. Please don't hesitate to share your questions with Roland on the chat, please. Now, This is our approach and vision. Now, what is the track record? So far, we have been deploying autonomous drone surveillance, security for ports, emergency and search and rescue, hybrid logistics and last mile delivery, inspections with key customers and partners, achieving efficiencies, ROI, and much faster operations with encouraging results that really showed us that autonomous robotics from a platform approach can really bring benefits to our customers. I want to focus on some specific projects that can be of interest to you here today. First, the autonomous drone surveillance that we have deployed and is today functioning with Telefónica and their headquarters in Madrid, where we have fleets of autonomous drones doing surveillance rounds in their headquarters. We are leveraging the power of 5G connectivity, live video and AI analytics, and a web video interface for monitoring. This is all connected to edge computing and live in their control and command center. Another use case where I always talk about the power of our orchestration platform is what we are doing with SEAT, the car manufacturer, and Telefonica, but it can be translated to any other type of sector, is the multi-robot orchestration, where we are combining two different types of drones and ground robots to bring component parts from one site to another site. And leveraging 5G and another type of connectivity. We are doing the hybrid logistics, last mile delivery, all these in less five times faster than the standard time that is being done today, showing how autonomous robotics and automated logistics can improve the traditional way of doing things. Another application where we are showcasing the power of a platform approach is the mapping of monitoring, in this case of Canadian forest, where we are working with TELUS. In this case, we did not have standard connectivity. We have leveraged the Starlink satellite connection. I know this is also relevant for the audience today. Some places where we don't usually have connectivity. We managed to map a large forest in Canada, integrated to mapping and a GIS platform, and to deliver a swarm management solution. Finally, another use case that is interesting here today is how our platform is able to orchestrate fleets of drones, RFID sensor tagged for autonomous security and live tracking with containers in the port of Bristol and Cellnex, with a private 5G core connected live with the command and control center and with edge computing. This is also a very interesting use cases that show also the power of edge computing, AI detection, and how we can connect the live tracking. So I have a question that I will reply later on. As we go. Yes, Roland.
Yeah, I'll summarize the questions when you've done your introduction here. So keep going for a bit here, and then we'll get into the questions.
Perfect. But please, the audience, we can interrupt also.
Absolutely, yeah. We're going to get into the questions here in a second. So get them into the chat or into the Q&A, and we'll address them.
Yes. So we can make it webinar type. That's not a problem. So this is another super exciting use case where we combine the power of our platform approach. And again, for our audience here today, the difference between a simple one-off deployment with a, let's say, drone site security solution and a platform that can integrate sensors, drones, and robots, here you see the difference. We can integrate RFID sensors, connectivity, and drones to make a much more powerful solution that will amplify the capabilities of each single robotics and each single system. And of course, if we want to deploy products and systems and solutions need to be regulation proof, we have a global partnership with EU Drone Port, and we have obtained permits in 8 different jurisdictions, going from Middle East to Canada. Now, what is behind the technology? And my colleague, also Kim Clement, CTO of the company, is here to answer more questions in the Q&A. What is behind the technology? So in terms of platform architecture, so going from left to right, so we were referring to, we transform individual robots into autonomous applications. So we have as you can see here, the ULAs. We leverage the network. So the ULAs is where we host our software, our companion computer. The platform, as you can see, the platform has 4 main capabilities: the device and swarm management, so the capability of bring different type of robots in a fleet. This is the first capability of the platform. The data management, so the capability to send and receive data to different systems or to the robot. The capability of to send the commands to the robot, so the mission management. And then the decision management, so that's the intelligent part of the platforms and the connection to third-party AI platform, for example, AI video analytics. Now, in terms of functional architectural layers, this is how that architecture is translated into an architectural layer. From L3 to L5, this is our platform. So if you ask me where are the, let's say, the robots and where is the customer? So the customer or the partner is in L6 and L7, and the robots are L1 and L1A and L1B, and our platform goes from L3 to L5. So if we go from the very bottom to the top, so devices, we have the devices that we control through the logical device control. So some of the robots, they come with intelligent chips that come on board. So we are able to deploy our platform in this board. Some others do not come with those. For example, drones, they need a GPU, and then we deploy our companion computer. That's where you have the layer L1C on the integration. And some others do not have that, so we need to deploy our companion computer. Then you have the network layer where we do need the connectivity to control the robots. Then I was referring to the 4 layers that we have for the platform and the core functions that we provide as Unmanned Life. Orchestration, this is our core business, yeah, and this is what we are bringing as an added value as Unmanned Life. So this is, as we are referring to, the simplified autonomous mission. We are able to configure robots. We are able to do the management capability of the mission, and this is done through the user interface. Then there is the decision making, the advanced capabilities that where we can do heterogeneous control of robots, real-time decision making, path planning, for example, that can be done through the platform. That's the decision management layer. The sensor data fusion that is done by the platform. This can be done on the sensors that are on the robots, or can be done on environments deployed for a specific use case. And then, as I was referring to, on the swarm control, where you have orchestration or coordination of multiple type of robots and IoT devices. For example, if you have a charging station for drones, where drones will land and sleep there, we will have a companion computer that will make that charging station as part of the node of the whole system of systems. Finally,
Nicholas, I think I can't wait any longer. I need to ask some questions.
Yes,
this is very interesting. And what I would encourage the audience to do is, we've got Edgar. Edgar just posted a question a little while ago, but absolutely, everyone's got to be wondering about, okay, wonder if this could work in my environment. And there's a bunch of questions that come out of that we probably won't all be able to get to today. But I do want to ask you a couple of questions. Maybe I'll let you talk a little bit about the security component first, because that is one of the questions.
Yes, sorry, it took me a bit longer on the layers. Basically the security part, and I will be very simple on this. We have 4 main layers of security, from devices to network, infrastructure, and platform. The device is very simple. It goes from the physical security on the robots to the encryption and the communications. Then we have, in terms of the network, then the second layer of security sits on the network part. We use the communication goes on. We use cellular communications, so we use the cellular standards, cellular communications network standards. So that's the typical encryption that you have from SIM cards, and all the policies that we use there. The third layer of security that we use is on the infrastructure itself. So we deploy our platform using containers, and we use the best practice of containers. And this is key in our approach and security approach. And then we also deploy our platform in isolated private networks. So sometimes there is no internet access in many of our deployments, so we have network flexibility. And then, in terms of platform, that's the fourth layer of security. We have coding best practice, the DevOps, CI/CD pipeline security, etc., etc. So these are the 4 mechanisms that we have today.
Yeah, I guess that leads very nicely into the first question here that Edgar posed, and I think this is an important one for us to talk about. Is there's a fair bit of complexity here, right? There's not a lot of other people doing what you're doing, and there's a reason why this isn't being done by customers themselves. To what extent do you have services that you bring to help to tie all of these different systems together, or do you have partners that do that? How do you approach that, or do you expect that you educate the customer and the customer does it? Like, talk us a bit through how that works.
Yes. So in terms of how we approach the deployment, so we work with our partners. In this case, with Cisco, we go together to the end user, and we start deploying this, and we educate our partners to work with system integrators, and we educate them in terms of what is the best way to deploy this technology. Okay. That's the best approach that we have found till date. For example, with network providers or with system integrators. We are educating them on how these platforms can be deployed and integrated with different robots. We are educating them how to integrate different type of robots into their network.
That's very good news. I think obviously you're not going to be able to scale to everywhere you need to be.
Exactly.
So I'm encouraged to hear that. I think it's also a good opportunity for any of the integrators who are on the call today, that this is an opportunity for you to actually integrate, work with, because a lot of you, the integrators that we work with at Cisco, have a software practice. They have an integration practice, right? So they know how to work with APIs. They know how to tie systems together. And so to be able to leverage your platform to do that is quite powerful, especially if there's some IoT background there in terms of data. Maybe let's talk about the data piece for a little bit, right? Because a lot of what you're doing is collecting data and then responding to that data. Are you also a data platform, or are you only an orchestration platform and you work with other data platforms? Maybe talk a bit about that.
So we are. Maybe I will go again to the functional architecture. So the data management. So we don't store the data, but as you can see in the functional architecture layers, and I don't know if Kim is here, but I didn't see him.
Oh yes, he's. We need him promoted to panelist to be able to answer that question or get online.
Because if Kim, you are here, you are feel free to also comment because I didn't see you on the list. But feel free to comment.
You promote Kim?
Yeah.
There we go. Yeah.
Okay.
So he's on now.
He's here. Okay. Perfect.
Hello. Can you hear me?
Okay. Perfect.
Yeah. Sorry, I couldn't unmute in the mode I was. Thank you for that.
Okay.
Richard.
Yeah, because
I think Nicolas already on the previous question already answered the fact that we use APIs. Maybe just to share on that we have an abstraction layer over there, both for the hardware as well as for the sensors, as well as for third-party or OEM applications. And via that abstraction layer, we can make plugins also dedicated to even legacy systems over there, because we know there's not much flexibility on the customer side. Yeah, that's indeed very, very well noted, Richard. That's indeed where we can collaborate also with system integrators. Then coming back to the data part, it is actually two-layered. Yeah. So the fact that Nicolas refers to that we don't store the data, like the business information systems, we don't build and we don't maintain. Of course, there's a part of data that we need to drive the solution. Yeah. So part of the data will be channeled to our platform to create a context, and that will drive the mission management in the field. There's a secondary layer of data, which is data that we collect out of the field that is meant for the operational insights, that is meant for business information systems to do analytics on top of them. This data we forward and we pass through to the business information system of our customers. Yeah. So there again, we work with APIs. We expose it to them in the format that they prefer it. We're quite flexible on our side on that. It is something that we collaborate. Yeah, we work together directly with the customer. We work together either with system integrators, and in the future, it's something that we want to expose over SDK so that also customers can build their own module to plug into the platform. That's going to make it more scalable. That's something that is non-existing today, but is on the roadmap for the company to build towards the future. Okay. Let's talk a bit about the communication part of this too, right? Because you already alluded to a few different communication options. You had an example of 4G, 5G obviously is what a lot of your work has been to date, just because of your ownership and partnerships. But you've also given examples of satellite, right? You've given examples of Wi-Fi. I know some of the robots that you showed on the picture there default to Wi-Fi, right? And so there's got to be some interaction there. Talk to me a little bit about how that interface works and whether you use the native wireless infrastructure or interfaces that are on robots, or whether you add your own module to do communication, and whether there's a routing function there. Talk a little bit about some of that, for whether there's multiple uplinks. There's probably a few different options.
Well, Kim, please go ahead, because I hadn't seen you on the list, but now that you are here, I have spoken already. So please go ahead.
I was hidden as a guest.
Yeah,
Yeah.
yeah.
It's indeed multi-layered, Richard, as you referred to. It's not one single solution over there. So typically, what we do is most of the devices on the market today are not immediately 5G ready. Yeah. So if we look at the 5G ecosystem, so what we do over there, we do augment them with a companion computer, yeah, which is running our end node software on top of that. And those devices that we leverage or install, we don't build them custom. It's devices that can be taken off the shelf also. We work also with different vendors over there, so we are flexible as our platform is a Docker. It can be installed on different infrastructures. What we do make sure is that these devices at least have PCIe M2 slots, so that we can extend them with the modems that are required for the specific network. So in case of a 5G network, we will install a Quectel modem inside, or a Qualcomm modem, or whatever modem is also certified by our customers or by our telco partners, because a lot of telco partners already have pre-certified modems in there. So there we are flexible on that matter. However, if you look into the solution of SEAT that Nicolas was presenting, there we have to deal with an infrastructure that was already existing. Yeah. And outdoors, they had 5G on a private network, yeah. But indoors, they didn't have coverage with that 5G network. So there we are leveraging a combination of 4G, which was already available inside their factory, and also the MRs were already foreseen by an industrial Wi-Fi module. We didn't replace those modules. What we did over there was we installed our software in a computer next to the existing infrastructure, and we have a local communication, and we are leveraging the same network over there. So there are, let's say, modular approaches possible. Of course, depending on the use case, certain selections of network are required also. If you really have low latency requirements or high bandwidth requirements, it's obvious, of course, that sometimes 4G is not sufficient. And I'm talking about, for example, surveillance and security missions where drones are carrying one or multiple cameras, streaming 4K video streams, not only of the camera, but also for the object or the obstacle avoidance that is around. One single drone, for example, has about 12 to 13 cameras installed already. Yeah, so that's a lot of data to be processed. Yeah, and then 5G becomes more and more important.
Yeah, I think this is an interesting slide, Kim, on what you are saying, and yeah, on why 5G is important, and we are all talking about now, and also what is coming, and 5G edge computing is what is going to enable certain use cases very interesting for the audience that is here in terms of site inspection, remote operations, multiple robots functioning at the same time, providing very valuable data for the end user. This is 5G edge computing is going to provide that.
And I would guess some of that is probably dictated by the regulatory requirements for wireless in the various places as well, right? We in our 5G deployments, that's one of the, probably it consumes almost as much time as the rest of the design is actually getting the licenses to do. I mean, you work with service providers that do have some of those licenses, but there again, if they're providing private solutions, then you'd have to agree to some sublease of spectrum and that kind of thing. So it's not a trivial thing. And that's where like satellite communication and Wi-Fi and some of the more licensed backhaul solutions could work as well. So that's one of the reasons we thought it was really important to partner with you as well, because you had this relatively agnostic approach to wireless. It made a lot of sense to give our customers that flexibility, right? So I think that's also really key. I have another question that's maybe a bit more operational than it is technical. But as I listen to you talk about the different use cases you have, I can't help but think that the efficiencies you talk about in terms of leveraging one drone fleet for multiple missions, that these missions probably move across multiple operating domains within the customer, right? So then who actually buys this fleet, and how is it leveraged across these multiple silos? Or do you have some practical examples of how customers have done that? Or is this something that usually just needs to be figured out on a case-by-case basis?
So yeah, this is a very good question, because now what we are seeing is that we have customers that have 300 robots, to 60 drones, that they are approaching us because they have all these robots, and they said, okay, now we have bought all these robots and we are realizing that we need to start managing them. And so the investments have happened individually, or let's say in bulks, in silos almost, and now this platform approach is functioning almost or happening organically. And what we are trying to convey today as a message is that there is an opportunity now to have this thinking on doing it at the beginning. So who is the right buyer? We see that inside security, and this is what I wanted. What is the product? That was my next slide. Is that we see that the first product that we are launching in the market is the what we call the use security, because we see that the first opportunity that we have to launch as a product is a security and inspection product, as a first subset of this robotics platform approach, because we see that there is an immediate need for security and inspection, where you can build your robotics roadmap with an immediate need, where you can have your regulatory approvals, because these type of sites are in the type of places where you can deploy. So these are the type of teams that have the buying power to start executing. Yeah, and we see that these are the security inspection teams. Right.
So when you say this service, so this is a use case example. Does that mean that if you're providing a service that you're focusing only on this, or is there like a tiered licensing model for various use cases, or how do you have that structured?
Well, yes. So we have the security and inspection use case, where you can build security and inspection for sites. You can add different type of robots, where you can build that robotics roadmap. But this is a very, let's say, a verticalized product. But if you have a platform approach where you are deploying on the servers of that big of that corporation, you can build on different use cases. We know from these customers that they have multiple use cases. It's not simply a one-site security. Typically, these customers, they have multiple sites. So we are talking about hundreds of sites where you can deploy, and with our approach, you can control multiple sites from one platform. So you can and this is the power of the platform approach. You can control from one command and control center multiple sites. Yeah.
So let me paint a scenario for you and see if I have this correct. Right. So so if you have a drone or a system of drones that's doing a site inspection, say of a refinery, and you might not be able to get into all parts of the refinery just because of the operating policies, but there's a large part of the outdoor area that is probably patrolled through this type of a thing, right? So then if the drone senses in its review of the site that there's an issue that needs to be dealt with, then the platform itself could dispatch either a maintenance personnel or even maybe a robotics platform to go and perform a task. Is that correct?
Yes, that is correct. I think today we don't have the time to go in detail on this product, but the idea with this product is that you can 3D map the area. You can connect that product to your site maintenance system. You can trigger, as we have the platform connected to different sensors, you can launch missions based on those triggers and alert mechanisms. And this is the power of an approach, platform approach system. Kim, please go ahead.
Yeah, indeed. You answered partially already on that part, Nicolas. So we have indeed triggered missions that can be deployed. These can be time-based, so it can be really on regular basis doing surveillance rounds. But it can also be triggered by external sensing mechanisms. One of them that we've done, for example, is with a LoRa server with different LoRa sensing systems on the background. And then these triggers are used. Either we know the geolocation of where the sensor was triggered, or either we get also the geolocation, and then we can send the drone to that situation. For example, if we talk about oil and gas, what is very typical over there is differential sensors that will only measure something on the moment that there is a pressure difference, or that but you don't know exactly what the problem is at that moment. I know a lot of people and friends that work in that field. It's a risk to go there. You don't know what the situation is that you will be facing. Here, robots can already give a first bird's eye view in the first place, but they could also do measurements, measure any potential gases that are in the environment. So people that are going on site are much better prepared for the situation on site. And then, for example, the second stage could be legged robots or mobile robots that go in on the ground level, before people go in.
Oh, that's perfect. Yeah, I was just going to say that the team that I was talking to in Singapore, they're actually looking at doing this in offshore platforms where they're trying to onshore a lot of the people working there, and actually using legged robots and surveillance drones as a proxy for a lot of the on-site inspections and people actions, right? So they can actually, some of them actually have legged robots already on the platforms that can go and read gauges or even turn valves, that kind of thing, if needed. And so that, I think this is a really, really important step to becoming autonomous in some of these very remote and dangerous operation environments. So, we're down to the last few minutes here. Nicolas, I've been kind of interrupting you with a bunch of different questions. Is there anything in particular you want to leave the audience with in these last few minutes?
Well, I think there were some questions, but what I wanted to leave as a key message is that what is important is that to start building a robotic, autonomous robotics roadmap, it's key to lay down a path for a platform approach from now for the next 3 to 5 years, and it starts today. You have all the elements. Robots are now ubiquitous, and instead of having this silo approach, you have an opportunity now. And I want to thank you for the opportunity for presenting, and I think that there are immediate opportunities now, but all this efficiency can happen.
Right.
Okay,
appreciate that. There is a couple of questions we didn't answer live. One of which is the SI, like how do we actually engage with the system integrators, and how do we work that piece out? And definitely I would invite the integrators that are on the call, if you're interested in working with Unmanned Life, definitely reach out to me. I think most of you know who I am, but definitely reach out to me, and I can orchestrate that a little bit with Unmanned Life. If I don't add any value in the middle, you guys can continue to operate together, but I would like to be a part of that conversation if it makes sense. The other question that was there is more of a technical architecture question. Maybe I'll let Kim, if you want to address that in the chat. It was around the 7-layer model architecturally that you have, and whether there's a correlation there from that to the Purdue model that we see in industry. I don't know that it maps exactly, but I think there's probably some similarities.
I think inspired is the correct word to use over here, because we notice when we are explaining what we are doing as a technology, it is really multi-layered. It's like peeling an onion. And to convey that message towards other companies, and especially if you're working also with telcos and bigger enterprises, we had to find a way of really showcasing where the layers sit and how we collaborate on that. So indeed, it was the inspiration for it, but it doesn't map 100%. It doesn't overlap 100%. So there are some layers where, due to the platform and the nature of the platform, that we had to shift, but it is inspired on that architecture, correct?
Yeah, and it's probably fair to say that a lot of the policy that exists there in the 62443 standard probably don't apply directly to the way that you operate. And so I think that's important to recognize from a security and policy perspective. So thank you for clarifying that. That was Nicholas, the CEO of Unmanned Life, giving you an introduction to their robotics orchestration platform. Please look them up online or reach out to me if you'd like a personal introduction. You can jump right into the next session of our Virtual Energy Summit by clicking on the next video.